There we go. Okay. So, find integrals of what I'm going to call non-cooperative forms. In the book, they calls them miscellaneous exercises. So, this is like other stuff. You guys are good up the back? Or? Yep? Alright. Yep. Brilliant. So, I give you this integral. Your thoughts?
That's for what you.
Okay, so you're going to do a U substitution? Okay. U substitution, not in methods. So you could use that though. So if you do spec and you want to do a U substitution on this, go nuts, you can do that. You don't get penalised for knowing more math. Right? Unfortunately for methods people, they don't know how to do that. So we need to look at it. First thing, what's the problem we're having? Right, it's a function divided by a function. Do we have a quotient rule for integration? No, not a hard and fast one anyway. So, we need to think a little bit more carefully and try to notice something. Alright, what I would suggest that you notice, if I derive the bottom, what do I get? 2x. Just 2x, right? So, I'm going to call this bottom bit now, I'm going to call that f of x. If I derive that, I get 2x. Well, that's pretty similar to this top guy. Is it exactly the same? No, but that's fine. So I'll call this I for integral. So the integral is equivalent to saying, now if I was to, do I want to say this way or that way? Yeah, we'll just say this way. So how does this get to be similar to this? Well, if I take f prime of x, f of x, right? It's not quite that, it's very close. What small adjustment do I need to make? Half, right? Because this is 2x, but I just want x, so I need a half times that. Yeah? Cool. Alright. Well, if I use integral properties, I can bring that half out front. Do we notice anything? So tell me who's been doing the homework. Right. Hopefully we know, since ln of f of x derives, I'm just going to say that means derives, actually, so y equals this, then y prime equals f prime of x over f of x. Right? Since that's true, if I'm going to integrate, well, this just integrates, so equals a half of ln of the absolute of whatever f of x or no, put f of x. Like that. Now, because it's methods, you don't have to use the absolutes. If you're in spec, you must certainly do. But no. Cool, so we've got this, great. So this is a half of ln of f of x, which originally we had, x squared plus. I'll do it properly. If that, but if in methods you just put brackets there, that would be acceptable for methods because they define it so that it works like that. Well, in this case, it doesn't even matter because it will always work for that anyway. So if you put it either way. Cool. Now, is that immediately obvious? No. Right. This is where you're starting to get into your 40 plus material. Right. Most of the time it'll be more like the thing on the right, but every so often they'll be like, oh, that's pretty easy, we'll leave that in there as a high flyer thing. So, what do you have to be able to realise? Almost always, it'll be this thing getting used, the ln of f of x. Almost always. The only other times are when you can split it up into separate fractions easily without using partial fractions. Not even that for spec. So yeah, if instead we have, let's just make one up. Say we have that.
Huh?
Okay, can we integrate that?
Yeah.
Okay, very quick again. Can you integrate it how it currently sits? No, why not? Right, you've got a function divided by a function. We don't have quotient rules for integration. We don't have product rules, so not enough. Very bad. So, yeah. Beautiful. Okay. What might be a good idea?
Separate.
Right, break it up into two separate fractions. Okay. So this is going to be the same as 2x on 3x plus 4 on 3x dx. Is there any problem? Can you integrate this? There's one more move that you have to make. Right, cancel those guys. Okay, fine. Integral of 2/3. 2x and 3, 2/3 x, whichever version you want. Integral of this guy. Okay, so we're okay with this, we're stumbling with this apparently. So let's make this even easier. This is the same as 4/3, so integral, 4/3 times 1 on x. Yeah? Okay, so we'll leave this here. Normally I'd put a plus c on here, but since I'm going to do another integral anyway, so I'm not going to bother. So that's 4/3 of the integral of 1 on x dx. Integral of 1 on x is? Now I need my plus c. Beautiful. Why did the half integral brackets? Yeah, scale and multiply, you can jump through. That's all it does is scale and multiply. Beautiful, so we've got that. Cool. Good. Done. That's all well and good. Usually you would have to add in something like x cannot equal 0, right? Because here we crossed out the x's, and if this thing goes to 0, we've got a problem. But it's already taken care of because element of 0 is already undefined anyway, so you don't actually need that in this case. But that's something to look out for, that if you ever cross out x's, careful, you might have just created a problem for yourself, so just consider it. In this case, it's already applied, so it doesn't matter. Beautiful. More commonly, you'll get questions like this. It'll be a double barrel question. This will be like part I, part double I, usually. Okay. I've got this function. I want you to find the derivative. Right? Go. You've got this. Find the derivative of that. Not the integral, the derivative. You should definitely be able to do that later. Go, go, go.
随便来一个，自己就知道，没事看我，随便来个字，不要。什么都会说一
We're
个。
going to be technical, okay.
不会，这一看就是很绝不可能，没有，这是因为你写过了，你每次都不带。不用是。
Or are you doing the whole thing? Oh, okay. No, that's good. I was worried that you were still deriving the first thing. So, geez, that's taking too long. Adam's done with the derivative.
Yeah, I'm just
Kinship's done. Yeah. So you're kind of still going with the derivative, or are you trying to do the hence bit, or are you just trying to do the derivative? Derivative? Okay. Jacob's done? Yes? Go. Stuart's done? No? You think? Okay.
I got something, checked it, it was wrong, fixed it, and I think
Guess we'll find out. Cool. Alright. F prime backs. First thing to realise is what? Product term, right? We're going to function times a function. Go. So, I'm going to call that u, I'm going to call that v. du to x, then plus u dv. Derivative of this is k over kx. Is that what we got? Cool. What do we notice? K's cancel.
K cancel.
And technically this should be absolute, so we're in method, so it doesn't matter so much. So we get X. Happy days? Is that what people got? Yeah. Cool. Okay. Beautiful. So we've done the first bit. Next bit. Hence find this. Okay. So the integral of interest is that. Okay. What happens? Do we notice anything?
Yes.
What do we notice?
It looks similar like the
Similar to the whole thing?
right one. The right.
Looks similar to that.
Yeah.
Suspiciously similar. Okay. How do I get from that to that, or this to the either way?
Times
Okay, I need a multiple of 2 and
plus x
plus x. There's one other thing.
minus x. Oh,
K has to equal
1.
1 specifically, yeah? Did I derive this right or no? Unless I copied that out, maybe that should be kx.
why is it your play
Oh, it should have had a k in the question. Otherwise, we've made it super simple. There we go, sorry about that. Okay. So now it's even more clear what's going on. Great. Now, I don't want to have to write all this garbage out repetitively, right? You can if you want. I recommend that you don't.
Yeah, cool.
So I'm just going to call the thing of interest I. Right? Sometimes I'll call it, because sometimes it's not integral, sometimes I'll literally just call it A and S. As in, don't forget, this is your answer. Right? But you can do whatever you want. So that's going to be I. 2 plus X. Okay, great. This is the thing I want to integrate. I should put. I should note. All right. I've got to change my notation here because I'm complicating myself a bit. We'll do this actually. We'll do that pink bit. Okay. So I've got f prime of x equals 2. I'll call this the pink bit plus x. Brilliant. What do I want to do to the pink bit? I want to integrate it. Okay, well, how about I just go integral dx, integral dx. Because then I've integrated my thing with it. Okay. It's in blue. The integral of f prime of x with respect to x is f of x, right? Almost. Plus c. Now, do I have to put it in here? No, why? Don't say no if you don't know why. Got another integral. I can put it on this side if I wanted to. Which side's going to be messier? The right side's going to be messy. The right side's got multiple pieces. This is just a 1. Right? So I'm going to leave this side alone and put all my constants on the right side, just so I can keep 1 pretty clean. Cool. Integral of 2p. Okay, so that's integral of p with a 2 out the front. Dx. Plus integral of x, half x squared, plus some constant. Happy, happy? Cool. What did we actually want? Integral of p, right? Cool. Okay, I should put p in. Beautiful. Well, this is what we're after. That's my answer. So now I've got this piece is my answer. I'm going to replace that with a and s just so I don't forget that's what I actually want to solve. You don't have to, you can leave it as whatever you want. F of x, we know what that is.
你说它是一个 integration 你说它是一个这样的东西乱七八糟的。那 f c 是 f 巴拉巴拉 d x 怎么我所有的是有加
Happy about that?
不是那个
Yeah, no. No, lost you.
理解问题不是因为我哪错了
Were you happy with it?
你他妈说
Yes,
c 是一
were you
个
happy on that one?
是一个因
Yes,
特
okay.
你看
All I've done from there, f of x, we know f of x
之后的
is
那个常数
So I've just replaced that. This thing, the integral of p of dx, that is this. And that is what this question is asking me for.
说了的，说的 c 就是原来的意思。
That whole thing is I.
看错了，可以看错。
Really? Okay, well, I is just the integral of p dx, which is this bit. That's the thing I'm after, so I'm just going to replace that whole thing with just answer. Okay? So we're happy there now? Yeah. Sylvia, okay or no? No. Were you okay there? Okay there? Okay there? No. Okay. So, okay, integral of the derivative is going to be back to the original function. Integral of 2p, I don't know what that is, but I can move the 2 out front. So that turns into this. Integral of x is half x squared, and then I need a plus c somewhere. So we're okay there. Cool. Next bit. Integral of p dx. The question was asking me for this. Right, I'm just going to call that I, just to give it a short name. So I is this. I'm going to call the piece in there p. Right? Doesn't matter what the letter is. Well, that's just the integral of p dx. So the thing that I'm looking for is equal to that. Well, that is this. So this part is the thing that I'm looking for. It's the answer I'm looking for. Cool? Okay. Well, great. I've got an expression with the answer in it. All I need now is to get the answer by itself. So move everything to the left side. X squared ln kx minus these guys off. All over. Cool? There's a little bit of leaping up if you want. Equals answer. You could have half x squared ln k of x minus a quarter x squared plus c. Is that equivalent? Yes. Why? Say again. Right, negative C on 2, is that equivalent to C? Why? C is just some constant, right? Now, this is a little bit bad notation. right? Okay, so I've got C and C here. So you could call this C1 and C2. Or what I usually do in my very lazy way is I go C star.
不是有一日太理
Just to say it's still a constant, it's different from this constant, I don't really care what it is though. So long as there is some indication that this and this are not the same number, it's fine. A lot of the time, if you have a C here and a C here, they'll let you get away with it.
作
But
弊用的呀，
you don't want to like be the one person that cops it that year.
真有
So
瘾。
either C1 and C2, if you make an adjustment like that. If there's no adjustment, you just have Cs, that's fine. If there's some sort of adjustment, some sort of indication that it's different, it's warranted. But that's that. Okay, so the gist of these things is, it will tell you, okay, find a derivative, and then if it says, hence find an integral, it means somewhere in what you just did is a massive hint. You should be able to find something that's, if it's not exactly the same, it'll be so similar that it'll just jump out at you. Right? And then it's just a matter of getting that piece by itself. Cool. That's it for today. Most of 11H is things that will turn up where, if you see it in an exam, a lot of the people will try to run quotient rule or something on it. And it's just like, that makes no sense whatsoever because quotient rules for deriving all this sort of stuff. So just take 2 seconds to think about, is this thing integratable the way that it currently sits? Overwhelmingly in this chapter, the answer will be no. So you have to manipulate. If you've ever got a question that says, derive this, now integrate this other thing that looks unrelated, it will almost certainly be one of these. Cool, cool? Cool. All right.